The next thing that we want to be able to do is evaluate these trig functions when the angle doesn't land on one of our special triangles, the 30-degree angles, the 45s, or the 60s. So let's go ahead and take a look at these three examples here. The first one we want to look at is the cosine of 360 degrees. So as with the other ones that we've done, I'm going to start out by sketching out my angle. Now 360 degrees would take us all the way around one time around the circle. But then we land right on that positive x-axis. And so if I try to draw something, all I've got is that line straight out from the origin to where I end. And I don't really know anything about that in terms of it being a special triangle, because it's not a 45-degree angle, it's not a 30-degree reference or a 60-degree reference. So what we can do to help us out a little bit here, if I imagine where I ended up, I know I'm going straight out to the right. I'm just going to call that a distance of 1. If it helps us to visualize it, we can draw this triangle with a height of 0. Now, I know that can't be a triangle, but if it helps us to get a visual on how to figure out these trig values, we can draw it out. So that way I'm looking at my reference angle is here next to the origin, like it always has been. We've got an opposite side of 0, and we have an adjacent side equal to 1. Now, if I want to find the cosine, I need the adjacent over the hypotenuse. The hypotenuse is really the same thing as the adjacent here. So in our case, we're going to get a 1 over 1, which is just 1. So our cosine value of 360 degrees is 1. Now let's take a look at this next one, the tangent of 270 degrees. So I know 270 is going to be straight down because that's going to take me all the way around, and then I'm coming straight down on this y-axis. Again, I can't draw one of my traditional reference triangles. So I'm going to look at this and say, well, if I've got a reference triangle here, I really know that this side coming out to the left or to the right, I didn't go anywhere. So that's not really one of the sides of my triangle, but I do know that I'm coming down 1. So looking at my angle here, my reference angle, if I need to find the tangent, this -1 now is my opposite side. The 0 is my adjacent side. So if I'm finding the tangent of 270, bring that over here, I could say opposite is -1 over 0. But we can't divide by 0, so I'm going to have to say that this is an undefined value. There is no tangent at 270 degrees because I don't have an adjacent side to the triangle. And in order to find a tangent, I need an adjacent side. So that won't work for us. If I look at the cosecant on this last one of 5 pi halves, the first thing I'd probably do is take this angle and convert it out to degrees. And to do that, we need to take the 5 pi halves, multiply by our conversion factor of 180 over pi. If I do that, the pi's will cancel out. 2 goes into 180 90 times. So I'm taking this and going 5 90s. So that's going to put us all the way around, would be 4 90s, and then one more would put us straight up on the y-axis. So if I'm trying to figure out the cosecant, again, I don't really have a triangle here because this horizontal side doesn't exist. I'm just going straight up 1 because my value is going on that y-axis. But in order to find the cosecant, I need hypotenuse over opposite, which they happen to be the same thing. So hypotenuse over opposite is going to give me a 1 over 1, which is just a positive 1. So anytime we're trying to find the trig values when we hit one of either the x or y axis, we can't use our traditional 30, 45, or 60-degree triangles. We have to just consider what would those sides be? One of the sides isn't going to exist because it's not really a triangle. So I'm going to have a 0 side, but then the other two sides are going to be the same length. The only difference being if you're going down or to the left, those are going to be negative values, kind of like we saw on that second example.